Welcome to MathFRIL. In this video, we're gonna talk about the golden rule of algebra. This is the fundamental concept and ideas, and it doesn't mean that this topic is in algebra that we're gonna talk about golden rule, but I want it that you can get a glimpse of what should be the general concept of our lesson before anything else, and it's very important in higher levels as well. So let's start with this golden rule. The golden rule is very important to understand because it's like life. You must make it balanced, and what you do not want others done to you should not be done also by you to others. And Confucius is very influential person. And in the modern era, this is how they translate it: treat others the way you would like to be treated. Now let's focus on our mathematical examples. So I have prepared three examples today in this video, and to start with, this x minus 2 equals 5. So the idea here is you must focus first on the equal sign or the equal symbol there, and you must understand which part is the left side of the equation and the right side of the equation. Very important, because for this we must not think as a whole already. We must solve this step by step or one step at a time. Focus on the left side first and right side. So in this example, x minus 2 equals 5. Our goal here is to isolate x. In all algebra, actually, we have to look for the value of a specific variable, which is commonly x value. In this example of mine, we have to apply the concept of additive inverse. And additive inverse is the way to eliminate the particular constant. And the idea here is you need to look for the opposite number of a number to get the zero or the idea of zero itself. In this, for example, positive 1, the additive inverse of this is simply negative 1. And if we add these two numbers, we get 0. And in that context, I want you to realize that all real numbers has its own additive inverse. Another example, you have positive 7. The additive inverse of this is simply negative 7. And we have, if we add it, we get 0. So going back to our example, in our example, x minus 2 equals 5. In order to isolate x here, we have to use the additive inverse. Simply put this way, for example, x minus 2, we have to look for the additive inverse of negative 2, which is, think of it for a minute or for a second, which is positive 2. And our solution now is negative 2 plus 2. We have to add 2 to all parts of the equation. This is now where the golden rule is very important. What you have done in the left side of the equation, we have added 2 there, and 5 plus 2 as well in the right side, we get 7. So as simply as it is, that's how we can use the golden rule concept. Again, we used additive inverse in this first example. Hopefully it's clear, and I hope the next step is to use the equality postulates. So this is the next idea in the equality postulate. We have to apply this in algebra in many sample problems. So equality postulates has a various ways: equality in addition, equality in subtraction, multiplication, and division. And the rest of it, we can apply that here in our next example. So we have here example number 2. We have 3x minus 2 equals, we've got here 5. So in this example, as you can see, we have a new number beside x, the positive 3 actually. Then the same goal in our first example, we have to isolate the value of x. commonly in all algebraic or expression, in order to get the value of x, we have to isolate the x in the left side and the variables in the other in the right side. So in this, we have two things to consider: the variable and the constant -2. So we have here, to make it clear, positive 3 na minus 2 equals 5. Again, we can use the additive inverse here because we have already see the -2. -2 plus 2 plus 2 in the left side, we have 2 plus 2 as well in the right side. So we already eliminate the -2 there, and we get 7 in the right side. Now, we have to use the golden rule. The golden rule states that what you have done on the right side should be done on the left side, and vice versa. In this case, we can use the division equality. So, equality postulate of division, there's a lot of name of it, but it only means one thing: what we have done in the left side should be done in the right side. We divided 3 in both sides because in the left we divide 3, and the right, and also in the right we divided it by 3. So we can say that 3 divided by 3 is just 1. So in this moment, we can say that our value of x is, so again, 3x equals 7 divided by 3 both sides according to the equality postulate of division, or division equality postulate. So we've got x equals 7 over 3, or 7 divided by 3, because 3 divided by 3 is just equal to 1. So that's the idea. It's not equal to 0 as what the idea in the additive inverse. In this case, it's just equal to 1 because this is the identity. So I just want to emphasize the following. First, you have to understand what is the additive inverse of a number. And second, you have to master the equality postulates. So it can be in the form of addition, subtraction, division in the second example. Now, let's level this up. Since we have done with the variable with a constant, and in this case, let's try fraction. 3 over 4x 3 over 4x minus 2 equals 4. So as you can see, there's a lot of things happen here, or can happen here. So I have here 3 steps. First, we just also need, or we still need, the additive inverse concept. So in the case of this positive -2 here, we have to add 2 in both sides. And as we eliminate the -2, we've left with 3 over 4x equals 6, because 4 plus 2 equals 6. And this, we already used the equality property of equality, which is the addition. And now we have to use the multiplication. So equality, this is actually the property of equality, or the postulate. In this case, we have to multiply both sides with positive 4 in order to read with the fraction in the left side of the equation, because 4 divided by 4 is just equal to 1, and we're just actually multiplying both sides by 1. 3x is the remaining, and 6 times 4 is just 24. Now we are not finished yet. Again, remember the isolate concept. We have to isolate the value of x, or the x itself. Since we have 3 here left and it's beside the variable x, we have to divide it both sides, the left and the right, by positive 3. And this, we've got 24 divided by 3 equals x. So I hope this gonna make sense to you. Thank you for watching MathFRIL.